RBE3001 is the third Unified Robotics course at WPI. Throughout this course, students will learn to operate the Open Manipulator X robotic arm, their experiences culminating in the final lab where they must program the arm to perform a pick-and-place sorting operation on multiple colored balls, placing them into their respective colored bins. The final demo is of the robotic arm picking and placing colored balls into their respective bins, as shown on screen. The robot begins in the idle position, while it takes a picture of the field using the external camera, located just off-screen. It uses this image to find the balls in view and determine their colors, at which point it will begin to sort them into their bins until the board is totally clear. Please observe the robot operating properly.
To implement forward kinematics, or FK, we used a DH table to calculate FK using the Denevitt-Hartenberg convention. We did this by using Z and X transformations from joint frame to joint frame to calculate the final transformation from the base frame to the end effector frame. We implemented this in MATLAB first using symbolic variables, and then transformed our symbolic matrix into a concrete function using MATLAB function. This was then called in the FK3001 function in robot.m, where we passed in all the necessary values. FK is a relatively simple process. The main challenge we faced implementing it was that joint 3 was offset from joint 2 by an angle we called phi, which had to be accounted for in the math for both the transformations from joint 2 to joint 3, and joint 3 to joint forward.
In order to calculate the inverse kinematics, it's crucial to first acknowledge that the arm has 4 degrees of freedom and position space only has 3. To overcome this, a constraint gamma was added to represent the angle of the end effector with respect to the ground to perform kinematic decoupling. Once the constraints match the degrees of freedom, the inverse kinematics can be properly calculated through a geometric approach.
With a working inverse kinematic algorithm in place, the robot is now able to calculate joint movements to be able to reach a specific point within a desired time. This trajectory is going to be curved due to the linear interpolation in joint space. To remove the curve from our quintic and cubic trajectories, a function that solves for a matrix of trajectory coefficients was implemented. The function then evaluates the trajectory for position, velocity, and acceleration at the current time. Using the position information fed into the inverse kinematic algorithms, our robot now can interpolate to the next step in the trajectory, repeating this step until the path is complete and the robot reaches its final and desired point.
To implement vision, we relied on MATLAB's camera calibration tool to calibrate the camera for the checkerboard, allowing us to transform image coordinates to checkerboard frame coordinates. Once it was calibrated, we implemented one more transformation to transform from checkerboard frame to robot frame, allowing us to get a pixel coordinate in UV and transform it to robot coordinates in XYZ. To find the balls, we implemented 2 stages of masks. First, a mask to remove anything not on the board from the image, and then, once that was applied, a mask to isolate balls of different colors. The masks and thresholding for the colors was created using MATLAB's color thresholding tool. Finally, we calculated the centroids of big enough blobs, or balls, left behind after thresholding, and used those coordinates to find the true centroids of the 3D balls in robot space by using some math based on the angle between the camera's line of sight and the ground.
In our final implementation, the robot first uses the webcam to take a picture of the state of the checkerboard, then applies the undistortion, masking, and transformation procedures to calculate the positions of each ball on the board in coordinate space. In addition to storing the coordinates, the robot also keeps track of which color the ball is, based on the color mask applied to find it, so that it knows how to sort it. The main pick-and-place function takes in both the position and color, and simply takes the robot to each necessary position to place the ball in the correct bin. It repeats this process for each ball detected on the board.
This thing is so extremely wide angle, my finger being like...
Photoshop and graphic designer by passion is all I'm gonna...
Run it! Bro! Honestly, consensus AI would be so great for this.
The news, Pearson? Everyone's Pearson? Oh, I'm sorry.
I'm actually really curious.
No, I'm gonna get me out of this. I'm a publisher.
What are the conventions that we're looking
That was
for?
unfortunate.
Wait, no, it's fine.
Definitely the Hardenberg.
Hartenberg?
Hartenberg.
E-E-R-G?
Yes.
E-E-R-G.